So one of the nice applications is that mg bar is proper, say over z. So this is a stack of stable curves of genus G. You can also do the version with marked points, but that doesn't make so much difference to this. If you want to prove this thing is proper over Z, well, you need to check some finite type stuff, but the sort of the key content is the valuative criterion for properness. And essentially that comes out of this semi-stable reduction theorem. There's a couple of subtleties. One is that, notice that we have to make this field extension. But that's basically because mg is a stack. So if you look into the valuative criterion for properness for algebraic stacks, then it's not quite as simple. You don't just require that you can always fill in the diagram with your evaluation ring, but you have to allow yourself to take a finite extension of the generic point of your evaluation ring. So that's exactly what we're doing here. Because you shouldn't expect to be able to improve this result. So that's one thing. There's also a slight subtlety in that here we require the generic fiber to be smooth. If I take a random discrete valuation ring mapping to mgn bar, then, sorry, mapping to z, there's no, and then a lift of the generic point to mgn bar, there's no reason why it should land in a smooth locus. So you have to allow that your generic fiber might not be irreducible, and you have to do a little bit more work, but it's not so terrible. There's another nice thing you can get out of this, which is Gaber's lemma. So this says, what is this saying? So S is a scheme. Maybe it should be excellent. I don't know, I forget. So suppose you have a scheme with a dense open subscheme and A over U is abelian. So then there exists an alteration S prime to S such that, well, A cross S prime has a semi-abelian model over S prime. So the proof of this is very straightforward. You just basically you just apply the fact that mgn bar is proper, and you do some fun like taking some. Well, you find a curve inside your Abelian variety, sort of as I outlined before, and then you end up taking the graph of some matched mgn bar and you get the closure of the graph, and it turns out to basically give you the alteration. It's all very good fun. The reason I mention this is because in one of the future talks, Julio will talk about trying to construct narrow models of abelian schemes over sort of fairly general base schemes, and he will assume always that his abelian scheme admits a semi-abelian model of the whole of the base. And this seems like a very strong assumption in general. But what this lemma says is that sort of you can always apply Julio's theorems after some alteration of the base.
Yeah,
so
given that the alteration, I mean, you also want the normal class divisor.
but you can blow up some more, right? So in characteristic zero, it's,
Yeah.
so
Maybe.
But
yeah,
you need some conditions on S,
yes,
right?
I think I do, yeah, but
Maybe normal, integral, Noetherian?
well, the
Things like
normal shouldn't matter because I can just take.
No, it matters. If you want to, if I take a family of elliptic curves and I want over a curve, right? And I identify 2 points where the fibers are not even isomorphic, then you can never extend.
But my alteration could just.
Oh, the alteration can undo that.
Yes.
Yeah.
But I agree
But
that.
what is an alteration for a general scheme anyway?
So I have in mind a proper surjective map such that there exists a dense open of the target on which the induced map is finite. But indeed, like if you want to put integral scheme, then you could say generically finite. It's maybe more standard, but they're all. I mean, it's all true. But I do think probably S should, like requiring S to be like Noetherian excellent is probably a good idea. So I'm sorry that I forgot to. I'm sorry, I forgot to check the assumption from this. Okay, is this a reasonable point to pause?
We already
we already
started,
paused.
but you can also pause.
Maybe we'll pause for like 5 minutes and then we can. I don't know, this is a good pausing point. So.
Would you plan on taking